a function name, 0 or more parameters, and a block of code. All code must be in functions in C. Let's make a working copy of func.c, and we'll paste this into our working project. I'm just going to comment this part out. We'll use that in a bit. Here we have a function and main, which calls the function. So we'll go ahead and save this and run it, and we can see how this works. Now, this is a very simple function. It doesn't take any parameters. It doesn't return a value, and it's simply called like this. And when you call it, the code inside the function's block is executed, which has this one printf statement. So the block is where things happen. We could have more things happen in the block. We could declare a variable. We could initialize the variable. We could do some math on the variable. And we could print the value of the variable. There are many things we can do in there. I'll save it and run it, and you can see I is 25. In fact, if we wanted to, we could simply return the value of I. And in order to do that, we need to change the return type to int. And then down here, we can print the value like this. So there we're actually using the return value directly. We're not even assigning it to anything first. We save this and run it. We see we get value is 25. So that's from over there. If the return type is void, of course, then it's no longer legal to return anything. And it's no longer legal to take that value. So if I were to try and assign this, say int x equals func, and put the x over here, this is no longer legal. If I save this and run it, it says void value not ignored as it ought to be, because I've declared it as void. So this type declaration, this actually dictates the type that the function is used as. So when I try to use this function like this, the compiler knows that that is a void value and I can't assign it to something. So if I give it an int type and I give it a return value, now the type of this function expression is now int, and I can assign it to an int and I can use it in the context of an int. And if I run this, I get the value that I expect. I could also pass parameters to func. In this case, let's just pass one parameter. We'll pass an int and we'll call it x. And instead of adding 25 here, I'll add x. So I'll use it like that. And now when I call it, I'll call it with 50. So we get a different value. So what this does is it passes this 50 into the function. Now the way that it does that is by declaring a new temporary variable and copying this value into that variable. So it's not actually using the 50 directly. It's actually copying it into the function. This is called call by value. And all functions in C are call by value. So if I save that and run it, now the value is 50 because it's getting added to the I, which was 0. In fact, if I were to have int y equals 50 and then pass the y instead, same thing happens. It's making a copy. It's not directly using y. So if I run that, that's what happens. Now, instead, if I wanted to actually change the value of x here, x equals 100, and if we come out here and also print the value of y, you'll see that y doesn't get changed. And that's because this is passing the value. It's not actually passing a reference to the variable. So the function has no way of affecting this y. So if I run this, you'll see y is still 50. If I want to be able to affect y, then what I have to do is I have to pass a pointer. So I can pass y like this. That's the address of operator, if you'll remember. And then this one has to become a pointer. And then I have to use it as a pointer in all of these places. So now my parameter is a pointer, and what I'm passing it is the address of a variable. And so now I'm actually able to affect this variable. And when I assign 100 to it, I'm assigning it through the pointer. So I'm dereferencing the pointer. And so that has the address of this variable. And so it's actually going to affect this variable. And then y will be 100. So we'll save this and run it. And you see that we're able to actually affect our variable. And so that's called pass by reference as opposed to pass by value. C is always pass by value, and I'm still passing a value. It's just the value is now a pointer. And so that's how I'm able to affect variables outside the function. And that's how I'm able to implement call by reference instead of call by value. So let's put this back to how we had it before, which was call by value. We'll save that and run it and see that it's working the way that we expect it. Now, if we were to move this function to after main, if I try to compile it and run it, I get a warning here, implicit declaration of func. And so the compiler was able to discern it, but it's really wrong and you don't want to do it this way. In this case, the compiler was able to tolerate it, but many compilers will simply give you an error. In order to properly use this function when it's used before its definition is to have a declaration. So I take the function signature, and the function signature is the return value, the name, and any parameters, just their types. The actual variable name is not part of the function signature. Now, it's common to include the name because it often gives a hint of how it's used, and so we'll leave that in there. Now you'll see this warning will go away when we save it and run it. So now that warning goes away because we've told the compiler exactly what that function looks like and that it will be defined later. What's really common is that the function itself is actually in a separate translation unit. It's in a separate source file, and it's linked in later. And what's even more common is instead of having this function signature here, to have it in a header file. So I'm going to uncomment this, and I'm going to take this function.h, and I'm going to copy it and paste it into our working project. We're going to open it up. And we see there we have a declaration of the function. That's actually not how we have it defined right now. So I'm going to copy this and paste it in there. And there's our declaration of the function signature. And now that's included in this header file, and this will compile and run without error or warning. So that's the common way to do this. Whatever functions you're using in a particular source file to have their function signatures in a header file. And what that allows me to do is if I have a set of functions, I can have all of those in one source file, and I can have all of their function signatures in the header file, and I can compile that as a separate unit. And then when I want to use that and link to it, all of those function signatures are in the header file, and I can simply include that header file in my main program and link to the code, and everything will work the way that I want it to. So this is really the common way to do this. This is how libraries are created. In fact, this is why we include stdio.h at the beginning of all of our programs, because functions like printf and puts that we use a lot are defined in stdio.h, and then the actual code is linked in with our program as we build it. So that's how our standard libraries work, and that's really how all libraries work in C. So the function is the basic unit of code in C. Everything starts from the main function, and all code must be in function blocks. Understanding functions is a fundamental skill for C and C++ programming. Now let's delete our working file.